with exactly one pair. Seriously? With one pair of opposite parallel sides. So it's not quite a parallelogram, because a parallelogram, the other two sides also have to be parallel. Okay, we just have one parallel side. Alright, and again we have a lot of vocabulary that goes with this. So first off we have our bases. Our bases are the parallel sides here. So I'm going to grab some colored pencils. I'm going to use 3 colored pencils today. If you'd like to use 3 as well, you can. I'm going to use red, yellow, and green. If you'd like to use those colors too, you can, but you do not have to. Alright, so for our bases are the parallel sides. So as I take a look at this trapezoid here, which sides look like they are parallel? Which sides look like they would never touch if they were extended? Is it going to be the left and the right sides or the top and the bottom sides? Yeah, top and bottom. The TQ is going to run parallel to SR. So these are our bases. These are our parallel sides. Bases aren't always top and bottom. Sometimes they can be left and right, depending on how the picture is. To show that they're parallel, we use these little arrows. Remember those little arrows that we learned back in chapter 3? We talked about these in 6.3 when we were talking about parallelograms. Alright, if you want to label that base and base, you could, so that way you know that those are the bases. Alright, and then we have legs. Legs are just the other two sides. You need to go there? No. You were there. Okay, legs are the other sides, so the other two sides that are connecting our bases. These ones are not parallel. Now, this is kind of a widely debated topic in math and geometry. Is this exactly one idea? Some people in some textbooks, they say it has to have at least one side parallel, but it's okay if we have two sides parallel. Our definition is saying it's exactly one. I don't know. It's pretty debated whether or not a trapezoid has to have exactly one or if it's okay to have two. We're going to go with exactly one because that just makes our lives a little bit easier as we go through it. Alright, now we need to talk about our base angles and our angles, leg angles, if you will. Okay. So first off, base angles. Here you go, Hawa. Okay, base angles is a pair of angles connected by a base. Pretty fancy. So as we take a look, our base angles, we have two pairs of base angles. So which angles are connected by a base? We can just use one letter for an angle in this case because as I look at like angle T, there's just one there. Naomi? Okay, so if I do angle T, which angle is connected to angle T by a base? Angle S, angle Q, or angle R? What would be connected to angle T with a base? T and S are connected by a leg, so T and Q. Yep. So T and Q would be base angles. What else? We have one more pair of base angles. What else would be a base angle? S and R. Good. All right, angles connected by a leg. So this time we're doing legs that are connected by a leg are going to be supplementary. We've used that word a lot this chapter, supplementary. What does supplementary mean again? They add up to 90, 180, 360. Supplementary means they add up to 180. Turn your music down a little bit. It's really loud. Alright, so as I take a look at our leg angles here in this picture, we would know that angle T, if I find the measure of angle T and I add that with the measure of angle, which angle is connected to T by a leg? S. So T and S added together would make 180 degrees. What other two angles, when I add them together, would make 180 degrees? Good, Q and R. Nice. So as we look, base angles are next to each other, connected by a base. Leg angles are also next to each other, but they're connected by a leg. All right, we have one more type of trapezoid that we're going to talk about, and this is called an isosceles trapezoid. Isosceles trapezoids are a little bit different. A trapezoid is where we just have one side that's parallel. An isosceles trapezoid, again, we're talking about a trapezoid, so we still have our bases. So I'm going to continue to color code my bases. I'm going to use the red for my base. This one, again, it's top and bottom. It's not always top and bottom, but these pictures are, so. Okay, we can show that they're parallel by using those arrows. We can also use like these triangle arrows to show that they're parallel. Okay, we still have legs. So again, I'm going to continue to use the green for my legs here. Okay, if you're not using colors, make sure you're at least getting the parts of the diagram, like the arrows are important. Where else have we heard that word isosceles with what other shape? Yeah, triangles. Good. What was an isosceles triangle? Do you guys remember? Yeah, where two sides are congruent. So same idea is happening here with congruent. It's that two legs are congruent. Okay, so the legs are congruent to each other in isosceles trapezoid. So as I look at our legs, we're looking at across these ones that aren't parallel. Those are going to be congruent. To mark two things congruent, we use little dashes when it's segments. So those sides are congruent. So if you're not using colors, make sure you get those dashes in there. Okay, now an isosceles triangle, remember when we had two sides that were congruent, we also had two angles that were congruent. I'm going to flip back really quick, don't panic. It's chapter 4, right? There's my equilateral. Isosceles. Remember with an isosceles triangle, we had two sides that were the same, which meant that two angles were the same, the angles that were across from those sides. We had those base angles. So it's the same thing here. Our base angles are going to be congruent. I'm just going to underline that with red. I'm not going to shade it in. I don't know, just to make a little bit more sense. This is where I'm actually going to use my third color, my yellow. So as I look at my angles, I'm looking at what's connected by a base. So connected by base down here, I kind of have this left bottom angle. So I'm going to use that arc to show congruent. And that's going to be congruent to the one connected by a base. If I go up, that's a leg. So I want to go across, kind of to the right there. This would also be congruent. So these bottom ones are congruent. But in an isosceles trapezoid, there's not just one base. When we had a triangle, there was just one base. In a trapezoid, there's two bases. So we also have these angles at the top. These angles at the top, though, aren't congruent to the ones on the bottom, so I'm going to use two arcs for that. But they're congruent to each other, so two arcs. So the ones at the bottom are congruent to each other, and the ones at the top are congruent to each other. Okay, and then last thing that we know about isosceles trapezoid, specifically for isosceles trapezoid, is that diagonals are congruent. Diagonals are congruent. Remember, diagonals means that it goes on the outside or through the inside. Yeah, it goes like through the inside. It goes across. So as I look through this, our diagonals aren't actual sides. So I'm going to use that dashed line showing it's kind of an invisible line there. And then same thing on the other part when we do that. It's a dashed line going through from corner to corner. Not plugged in. Thanks. They're on my desk right now because I'm down to just one box. All right, so we just have two quick examples here, and then we do have one more thing about trapezoids that we need to talk about. So first off, is this an isosceles trapezoid? Do we have a pair of congruent legs? Yep, good. Our legs would be Q to R. What's another leg here? Good, ST. Those are our legs, which means our bases would be RS and I am a cutie. Thanks for saying that. I'm hilarious. Just laugh. QT is the other one, or T to Q. All right, so if QS, is QS a side or is QS a diagonal? Good, I heard diagonal. Good, QS is a diagonal. Then it wants to know RT, the other diagonal. What do I know about my two diagonals? They're congruent, so how much is RT? 17. Congruent means that they are the same or that they are equal. All right, so the last one, number 2 here, and then we just have one more thing that we need to add on the next page. Okay, we have QRS is 115 degrees. We want to find RQT. So QRS is this top angle here. Okay, it's at R. It's going from Q all the way over to R, so it's not getting intersected there by that diagonal. That's 115 degrees. I want to know what is RQT. RQT. So we're talking about this angle below at Q. Is that angle going to be congruent? Is it connected by a base? Are R and Q connected by a base? No, what are they connected by? A leg. So these are not congruent, so I'm going to use two arcs there showing they're not the same. But when I have two angles that are connected by a leg, this isn't necessarily just for isosceles triangles. What are leg angles? What do we know about angles that are connected by a leg? They are supplementary, so they add up to 180. So if I know one angle is 115, how can I find the other angle? Good, subtract from 180. So 180 minus 115. Bless you. We get 65. So the measure of angle RQT is 65 degrees. Get out of your computer, Mohammed. Alright, we have one more thing with trapezoids that we need to talk about. We need to talk about the mid-segment. So you are going to get one more glue in. It's really small, so I'm going to glue it on the next page. We do have a definition to write, so you probably don't have enough space on this page to write it. So go ahead and glue this in on the next page. It's a really small thingamabob. I've got one. Once it's below it. Alright, so go ahead and glue this in on the next page. Give me 2 more seconds here. Do you have it pulled up on your computer? Then I can just put it. I'm not logged in yet. Sorry. Not something I got done this morning. Alright, if you want to find another color that we haven't used yet, maybe like blue, you could do that. If you're happy just reusing one of the colors you've already used, that's okay too. I'm going to switch over to blue personally, but you do you, bro. Alright, we're going to talk about the mid-segment. Mid-segment is a little bit different of a term that we haven't talked about yet. What does that prefix mid tell us? Mid tells us it's in the middle. So our mid segment here is VY. We're going to write kind of like a big definition. It's not that big. It's just a little bit big. Make sure you bring your computer with you. Appreciate it. Okay, it's the segment that connects the midpoints of each leg. The segment, or the line, that connects the midpoints of each leg. So what that's telling me is in this picture, in this diagram, V is a midpoint. So F to V would be the same as V to C, because V is a midpoint. So I'm going to do that little tick mark showing it's in the middle. And the same thing would happen on the other side. Y is another midpoint. But these aren't necessarily the same, so I'm going to do 2 tick marks here to show that this E to Y would match Y to D. And really it's just like we're taking that trapezoid and we're just cutting it in half, or cutting it down the middle. It's not really in half because the 2 parts aren't equal. We're just cutting it in the middle. And we have a certain theorem that goes with this. It would be that VY, that mid-segment, is equal to, it's the average of the bases. So to find average, remember you add and divide by how many there are. So we're going to add our bases. So FE is one base, plus our other base, the bottom, CD. And then we divide by how many bases there were, which is 2. Alright, so last problem here, number 3. You guys are crushing this. I know it's kind of a long set of notes. That's why there's no extra homework tonight. Alright, number 3, we know FE. We're going to just keep using the same picture because I didn't want to redraw one. We're going to say FE is 6. CD is 18. I want to know how much is VY equal to. So just based on our formula, we should be able to find that mid-segment, that length. So first thing we want to do is identify which ones are the bases and which one is the mid-segment. So is FE a base or a mid-segment? Base. What about CD? Base. And what are we trying to find? The mid-segment. So we already know our bases. We don't need to solve anything. We're just going to plug these 2 numbers into our formula and find our answer. So VY would be equal to, in parentheses, what's one of the bases? 6 plus 18 divided by 2. We're finding that average, that middle. So what is... If we did our order of operations, we'd start with our parentheses, 6 plus 18, 24, divided by 2, so VY would be 12. We don't know what we're measuring in, if we're measuring in centimeters, inches, feet, miles. So we're just going to use that word units to show that it is a length, it is a measurement there. All right, we had a lot of people come in late, so I want to talk a little bit about our week here. Our notes today were a little bit longer. You still have quite a bit of time for work. However, it is split up into 2 parts, so tomorrow we'll do the second part of 6-6. It'll be our last set of notes.